Okay, I don't have a lot of time today, so I'm doing 5 quick computational questions similar to the ones that you have on your knowledge check. Got 4 problems on Georgia. Those 4 problems will be done similar to the 4 problems that I do on apartments. And then I've got one more question at the end that's done on the ice cream data set, which would look very similar to the one that you do for the creatine or creatinine data set. Okay. The apartments data set contains 67 other apartment complexes along with the rent, square footage, and other dummy variables indicating whether or not the unit is furnished, has in-unit laundry, and whether or not the complex has a pool. We are going to use mutate to create a variable called square foot premiums. I'm going to highlight this because it's a big deal. Square foot premium, which measures the ratio of rent to apartment's area. Now, I kind of find it crazy that I have to say this, but a ratio just means you divide the things in question. So ratio of rent to apartment area means take rent and divide by apartment area. Sometimes they'll be nice enough to tell you how to define it. So there it is right there. Sometimes they'll tell you that. Sometimes they won't. And you should know that the word ratio, you're a UT student, damn it. You should know that ratio means take the first thing and divide it by the second thing. Okay, so we are going to create our variable. A lot of mistakes that I see people make is they take, whoa, careful. That's one of the mistakes, is having my cursor go all the way down. One of the mistakes that I have or see people make is they just take the apartments data set and they pipe it into a mutate and call it a day. This might work. Let's see what happens when I take apartments, pipe it into a mutate where I define a new variable called square foot premium and take rent divided by square foot to get that number. You can see that on the right side, I have this column called square foot premium. And you might think, wow, I did it. But look at the apartments data set over here in my global environment. I don't have a variable called square foot premium. You could even click the apartments data set if you don't believe me, and square foot premium is not up here. So what did I do wrong? I didn't assign this a name. You need to assign this a name. You can call it apartments 2 if you'd like, and now you have a new data set called apartments 2, or you can just overwrite the data set you created. So you could do apartments 2 or just overwrite the old data set and now use apartments. And look, lo and behold, when I go back into my apartments data set, now I have my square foot premium variable. Okay. Cool. Now I've made this, and this is a mutated variable or a created variable that I need for all 4 parts, all 4 problems that I'm going to do. Okay, make a 95% confidence interval for the differences in average square foot premiums of apartments based on whether or not they're furnished. So what we're going to do this is say apartments underscore boot. You can give it whatever name you want to. You could say boot apartments. You can call it diff boot. You can call it diff mean boot. You can call it any number of things that you want. I don't care what name you give it. Just give it a name that you like. I called mine apartments boot, and I'm going to set that. I'm going to say do equal or do 100 times. I don't want it to run very long because I'm in a hurry. So do however many sort of iterations you need to do. It might be 10,000, it might be 1,000, it might be 2,500. I don't know. So do open parentheses, tell it how many iterations you want. And we're doing a difference in mean. How do I know I'm doing a diff mean? Differences in average square foot premium. So we're looking at differences in averages. And by the way, I've talked to you about this in knowledge check 10. How do I know whether something's a mean versus a proportion? Well, what question am I asking about each apartment? I'm asking, what is your square foot premium? And each apartment tells me my square foot premium is 1.26 or my square foot premium is 1.12 or what have you. When you see this, what that means, this is a number, this is a numerical answer. Because it's a numerical answer, it's a mean. As opposed to a question like, are you furnished or do you have a pool? Well, those answers are either yes or no. Those are indicated by the fact that I have a 0 or a 1 here. So bear in mind that prop questions are ones for which the answer to the question is yes or no, whereas mean questions are the answer to the question of whether or not, but what the square foot premium is, for instance, is a number, which it would be. So we're going to do diff mean, and we want to see a diff mean in the square foot premiums as broken down by whether or not they're furnished. So that's what this means. You can kind of read this as diff mean. What I want to break down, and then tilde what category I want to break it down by. In my case, I want to break down square foot premium. I want to see the square foot premiums broken down by whether or not the unit is furnished or not. So that's how the diff mean should be viewed here. This is for diff mean only, or diff prop, I guess. So we're going to run this line, and we're going to do convent apartments boot. Once that runs, notice that this interval does not capture 0. So that's one thing I'm going to point out, is that the result, whatever result that is, is statistically significant because the confidence interval does not capture 0. Hopefully we can agree that 0 is not between 0.111 and 0.34. So for that reason, the result is statistically significant because the interval doesn't capture 0. However, how do I know which premium is bigger? Or how do I know the premium for square footage? Sorry, let me try that one more time. How do I know the square foot premium is bigger for furnished versus unfurnished apartments? This is where a preliminary running of mean, this is just mean, of square foot premium broken down by whether or not the apartment is furnished, and data equals apartments. So if I run this, I get 1.06 versus 1.28. Well, 1.28 is underneath the 1, which means that would be for a furnished apartment, and the 0 means not furnished or unfurnished. So 1 is the thing that the dummy variable represents. So in the case of a 1, 1 means furnished, 0 means not furnished. So just understand that a dummy variable is defined to be 1 in the presence of that thing and 0 in the absence of that thing. Notice that furnished premiums are bigger. 1.28 is bigger than 1.06. So I would say an answer that says furnished apartments have a higher square foot premium, and the result is statistically significant because 0 is not captured by the confidence interval. Cool. One other thing I want to say about this is that for a bootstrap, this is a bootstrap, guys. You should know this by now. Bootstraps need resampled data, whereas for this single mean calculation that I'm doing, I don't need to resample because I'm not doing a bootstrap. So just bear that in mind. Let's do it all over again. Make a 95% confidence interval for the difference in average square foot premiums of apartments based on whether or not they have a pool. So honestly, I'm going to copy this and paste it down here. And I'm going to do the exact same thing that I just did. But instead of doing furnished, I'm going to do pool. Cool. Now it makes my bootstrap. I'm going to do confidence interval. Notice this time the confidence interval does capture 0. So I would say the result is not statistically significant. Not statistically significant because the confidence interval captures 0. Furthermore, I want to know whether an apartment complex has a higher square foot premium with a pool versus without a pool. So we'll do that preliminary calculation of square foot premium as broken down by pool using the not resampled data set apartments. I see that pools or apartment complexes with pools has a premium of 1.07, whereas the premium for complexes without pools is 1.1. So complexes without pools have a higher square foot premium, and the result is not statistically significant. Let's do it a third time. Make a 95% confidence interval for the differences in average square foot premiums of apartments based on whether or not they have in-unit laundry. Cool. It's going to look the exact same. It's going to look almost identical to what we did before with pools or furnished, but this time now I'm doing laundry. That's all I need to change here. Of course, I misspelled laundry, so laundry in unit. Laundry in unit. Make sure you spell your variables right, kids. Laundry in unit, put that there. Okay, so let's look at our confidence interval of our apartments. This one is significant. The confidence interval does not capture 0. And furthermore, units that have laundry have a higher square foot premium than apartments that do not. We can see that 1.13 is bigger than the 0.979. Okay. Lastly, we've got a fourth question. It's a little bit harder. I have to create a new variable aside from the one where I needed to do the square foot premium. I need to make one for whether or not the unit is considered near or far from the tower. So this is a categorical variable. I'm going to define a variable to be either near or far from the tower. And the new variable I'm going to create, I'm going to call is far. Okay, so that's the name. The variable I make is called far. You can call it far from tower or close to tower or close or far or whatever you want to call it. I called mine far. So we're going to take our data set and set it equal to itself. Remember, we want to overwrite the old apartment complex data set. Take the apartment complex data set, pipe it into a mutate where I'm creating the variable called far. And now I have an if else. And I don't know why, but everyone freaks out about an if else. If else does the following. It does a check. It checks to see if that thing is true or false. If that result is true, it will replace the variable with the first argument, or I guess technically the second argument, because this is 1, 2, 3 arguments. It replaces it with, you could say, the first argument after the check. So if this statement comes out to be true, your variable becomes this. Otherwise, if the statement is false, it becomes this. That's it. So the check I want to run is I want to see if the apartment complex is at least 0.5 miles from the tower. At least means greater than or equal to. And so that's why inside my miles, my if else, I put miles from tower is greater than or equal to 0.5. If it's greater than or equal to 0.5, then I'm considering it far. Otherwise, I'm considering it near. That's it. So I'm going to create this line, or run this line rather. Of course, it's not miles from tower, it's distance from tower. I'm an idiot. So make sure it says distance from tower or whatever it is that needs to say distance from tower. And then you could always check to make sure that variable is created. Yep, sure enough, it is. It's called far. You can even do a quick little spot check. Let's see what the distance from tower is. This says 0.6, so this would be considered far. Yep, checks out. This distance from tower is 0.3 miles. That's considered near. Okay, good. It seems like my if-else ran as it should have. Now that I've created that variable, that's what I'm going to put inside my diff prop, or sorry, my diff mean rather. I'm going to run my bootstrap, then going to run my confidence interval. Seems like lower to upper does not capture 0. And then I'm going to do mean of square foot premium is broken down by far. It seems as though apartments close to the tower have a higher square foot premium. Right near gives me 1.23, whereas far gives me 1.06. So apartments that are close to the tower gives me a higher square foot premium, and those that are far give me a lower square foot premium. But this interval that we did in the comments interval we created here does not capture 0, so it is statistically significant. Okay, and one last question that's not like any of these, so we don't need these whatsoever. We have using the ice cream data set, bootstrap a sampling distribution for the slope coefficient in the model that uses, or they'll say in the linear model. In the linear model that uses temperature to predict scoops sold. What is the standard error in the slope coefficient? So I'm going to call it ice cream boot. I'm going to do 10,000 iterations. And this time it's not a diff mean or a diff prop. It's a linear model. It's a slope coefficient. Slope coefficients, linear models, all these things should convey that you're doing LM. If you're doing diff mean or diff prop, why did you do that? It's not a diff mean. I'm not looking for differences in proportions or means or anything like that. I'm looking for a slope coefficient in a linear model. So I should be doing LM. We are trying to predict scoops from temperature. So using temperature, the thing I'm trying to predict goes on the left, which in this case is predict scoop. And the thing that I'm using to do the prediction is temps. Just in case you didn't know this for linear model, I sure hope you would have known this by now. Thing you want to predict, and the thing you use to predict it. Okay, that's how LMs work. And stop putting minuses here. I can't tell you. There's like 20 of you who put minuses here and tell me, Andy, what went wrong? I don't know what went wrong. It's a tilde, damn it. It's not a minus. Okay, so we've got scoops tilde, scoops tilde temperature, yeah, or temps, I guess is the name of the variable. Data equals resample ice cream. It's a bootstrap, so make sure you resample. So let's run this bootstrap, run, check the stop sign. Okay, and then we're going to do confident ice cream boot if you want it. There's your comments interval, although I don't think you need that. What I want is the standard error in the slope coefficient. So I'm going to take the bootstrap, my boot that I just created, the ice cream underscore bootstrap sampling distribution. I'm going to pipe that into a summarize, and the summarize will create a variable. I can call it whatever I want. I can call it banana for all I care, but it's equal to the standard deviation of temperature, which is my slope coefficient. So run this. There's my standard error, and I'm done. See you guys next time.